Good morning, and thank you for joining us on our third and final day for the Digital HPC Roadshow. My name is Maz Lopez, and I'm Head of Marketing for Boston. We have got a great day ahead with keynotes, content, and training from our partners and leading industry vendors. I just want to take the opportunity to thank the Centre for High Performance Computing, Supermicro, AMD, NVIDIA, Vscaler, and the Boston Training Academy. Without their support, this event wouldn't be able to happen. In today's agenda, we're excited to be joined by AMD, as well as members of the Boston Enterprise Solutions Group and the Boston Training Academy. And shortly, we're going to begin our keynote. But first, a bit of housekeeping. Once again, we are going to be having Q&A after our sessions. If you want to ask something to our speakers, you can click on the question mark icon in the Teams app and type it in. And time permitting, we'll answer as many of your questions as possible during the event. Attendees who provide at least 7 passwords by the official close of our event can unlock training given by the Boston Training Academy that's taking place tomorrow morning on the 2nd of October. This morning's code is POWER, and I think you'll find out why in just a second. So without further ado, I'm going to hand over to David Power, Head of HPC for Boston, for today's keynote.
Thank you, Maz. And good morning, everyone. My name is David Power, and I head up the HPC division at Boston. And today I'm going to kind of just reflect slightly on kind of where we are within the industry and cover off some of the new trends and emerging technologies that we're starting to observe with our customers. So with that said, I mean, let me just start off by introducing ourselves. I mean, Boston is an organization that's been going for the last 30 years. And we've always had this pedigree of, working with the very latest technologies and being very HPC centric. So, part of our innovative technologies, we bring technologies to market first. We use best of breed components, and we try and optimize our solutions to be incredibly cost effective to maximize people's investments. We've been a long-term partner of Supermicro's, and more recently, we're a partner of the 2CSI group as well, with offices spanning EMEA, APAC, and the US as well. In terms of our locations, I mean, we have a strong presence in Europe. Our South African organization was spun up about 2 years ago as well, and we're really starting to see huge growth and excitement on that side. And we've got offices and engineering and support teams littered throughout the globe as well. So regardless of where your location is, we'll have the local sales team and support team and engineering team around you to work with you and fine tune any solutions that you may need. So part of our differentiators, we've always had a focus on HPC and have done since 1992. And I think that's part now of our secret to success is that we've really focused on the high end in delivering clusters at scale and delivering technologies that can deliver the absolute best performance. And I think what we're starting to see now in the industry is rather than these technologies being consumed predominantly by academic institutes, we're really starting to see commercial adoption of these technologies and a much broader acceptance of HPC technologies across a wide variety of use cases. And the fact that we've been so focused so heavily on these technologies from the get-go, I think that's put us in a fairly unique position to be able to ride that sort of wave. We've got an incredible team of engineers, so the vast majority of our organization is actually invested in engineering. So anytime that we're working with technologies, our engineers will actually spend the time in the lab working with it, trying to break it, fixing it, rolling it out, checking its commercial viability, and integrating it with other products that we actually have. So before we actually bring anything to market, it will have gone through months of internal testing to ensure that it's working, performing, and stable as expected before we bring this to our customers. We like to work with customers very closely as well. So we have a Boston Labs facility, and in this facility we have most of the latest technologies. We often have technologies that are available prior to their launch. So new fabrics, new CPUs, new accelerators, we tend to get them prior to in advance of their launch. And under NDA we can provide remote access to these technologies to our customers, and then we like to engage in that kind of pre-stage validation with customers as well. So this is an area where people can bring their applications, their data sets, test and evaluate new technologies, work with different storage products, interconnects, CPU technologies or accelerators, and just ensure that whatever workloads are being run on the technologies, that the right solution is being selected, architected, and then delivered to the customer, so that there's no surprises when it's actually brought up and delivered for them. In terms of some of the projects we've worked on to date, I've just taken a very small snapshot of some of the successful ones. We've been a long-standing partner of CERN, so we've been working with these guys for long over a decade, and we've won repeat business out there because of our dedication to this collaborative approach towards solution selling. We've over 50 petabytes of storage out there and well over 100,000 cores. We've even managed to deploy close to 1,000 servers as part of a single deployment in just a matter of weeks. And over that time, even with CERN, we have encountered issues with certain components over the time. And I think part of the reason they've stuck with us over this time as well is that we've never backed away from any issues that arose. So there was certainly one or two issues that we had with perhaps drives, with perhaps firmwares, and we brought in the respective manufacturers to analyze and debug and assess everything that had actually happened on there, and we had numerous fixes put in place as well. So even when problems do arise, we stick by customers and ensure that everything gets resolved, gets fixed, and is suitable for their production environment. So that's been a long-standing customer of ours, and we look forward to many more years of collaboration with them. We've also been working more recently with the Sanger Institute here in the UK. So this is a genomics centre who do a phenomenal amount of research into gene sequencing and so on. A number of years ago, we were speaking to them about the problem that they have with external collaboration. So they had this large-scale internal HPC cluster that was being used for their internal research, but part of the challenges they were facing was that they were really starting to open up more global collaboration on a much wider scale, and getting access into that system was quite challenging due to the internal security restrictions that they had in place. So they changed their approach back in 2014, and they started to investigate the creation of a science as a service platform. And this was like a cloud environment that's set between their internal HPC infrastructure and the external internet that allowed external collaborators to come in, as well as their internal researchers, and create secure environments where people could collaborate globally with them. Now, since that initial proof of concept, I think this platform has been hugely successful, and we've been working with them for pretty much every year since, in terms of delivering upgrades, additional storage, and additional compute to them. But it was it was a great project and challenge to kind of see this more global approach towards collaboration, and this Sanger group trying to open up a lot of the research that they're doing for the for the benefit of the wider world. So it's another project we're incredibly proud to be a part of. And then more recently, again, actually we've been working with Genomics England and Daimler. So again, with Genomics England, we've actually been migrating their platform off of a public cloud. So this was an organization that was set up by the UK government to sequence 100,000 genomes, which at the time was hugely ambitious, and they were way ahead of their time in terms of the other sequencing organizations that were challenging these types of data sets. So they initially spun up their environment in fully in a public cloud, and once they'd achieved the 100,000 genomes sequenced, the follow-on project was actually going to be looking at how to sequence 5 million genomes. So it was quite an exponential increase in terms of not just the data sets, but also the compute and also the costs. So they extrapolated what it would be in their current environment and quickly realized it wasn't going to be financially viable. We've since then tendered successfully with them, and we now run a managed service there for them. So we've actually put our vScaler cloud platform into their environment. We run it as a managed service for them, so they still get all of the benefits of cloud infrastructure, elasticity, on-demand resources, reconfigurable elastic infrastructure. But we actually take care of their HPC infrastructure on a day-to-day basis and allow their users just to come in as scientists and just consume the actual system. So they've no longer that administrative burden of managing the environment, and they're still able to consume it almost as a cloud service. But we've been able to offer them a dramatic reduce in their overall costs, and as they start to scale out to work towards this 5 million genomes, this becomes a much more financially viable project as a result of the work that we've been doing with them. So just to kind of summarize in terms of our services and our approach towards high performance computing, we've got engineers, experts across the board who enjoy engaging with customers in all stages of the HPC design practice. So we often try to engage as early as we possibly can with customers, where we can actually bring them into our HPC profiling center or the Boston Labs environment. And again, this is an area where customers can bring their workloads and data sets, test and verify them on some of the latest technologies, and just ensure that what they're going to procure is going to be the most cost effective for them for their specific workloads. Once we've onboarded a customer, the projects team will then sort of kick in for the actual delivery of the cluster environment. So again, with these complex systems comes great risk in terms of component interoperability. So our projects team will actually work with the end customers. You'll have a Prince2 project manager allocated as a dedicated point of contact. We'll be doing things like site surveys, project test plans, Gantt charts to confirm lead times and everything else. And we get a full documented scope of works to finalize all of the work that we actually do with the customer. In our actual build facility, we have a dedicated HPC area. So this allows us to do full system integration in our facilities before it actually ships to the customer environment. And this allows us to build HPC clusters in full as they would be on customer sites. So this includes all of the networking, integration with the parallel file system or storage, the cluster software stack and applications. The system is fully built as it would be on site, and we can even allow customers join our engineers during the time when we're assembling it as part of the knowledge transfer and training process. Or we can even offer them remote access into our environment to do some of the pre-validation tests on the system before it ships, so that they're happy with the levels of performance on the cluster before it gets to the customer site. Our team then typically handles the full cluster install. So we go through an exhaustive checklist in terms of validating the system is still fit for purpose after being reassembled on site. We have a 100-point health check, which ensures that all of the floating point operation performance of the CPUs, the memory bandwidth, the memory latency, disk throughput, disk bandwidth, network latency, network bandwidth, all of those individual components are checked and validated across the cluster to ensure that there's no single component which is degraded in any way or not performing as expected. And then we'll do a full system-wide benchmark to ensure that the system is performing at the levels it actually should. Once the system is over, we have the Boston Training Academy, who can come in and actually perform any level of training with end customers. So whether that's cluster administration, application or performance tuning, working with things like GPUs to accelerate applications. We have a full suite of training packages that we can offer customers as well to help upskill any existing customers from the levels they're at to be able to manage and run the system at a very, very efficient level. Finally, then, as part of our managed service team, we can also take over the day-to-day administration of the system. So in terms of managed services, we've got 4 different sorts of levels of service that we can actually provide. So the basic one just covers basic hardware break fix. So this is on-site engineers for any sort of hardware components that may degrade over time. The second level is where we actually go through and can actually take care of the day-to-day operation of the system. So this is when we integrate our alerting system with our support help desk. So in the event of any nodes going offline or components being reported as faulty, our ticketing desk will pick up these notifications and alerts automatically and instruct engineers to get there on site next business day or within 4 hours or whatever the SLA level is. Improving on from that, we have ongoing administrative services. So this is where we can actually go in and be more proactive in terms of how the cluster is being used. We can assess the queue, the scheduling policies, the overall resource usage, and then have monthly meetings where we can actually report the overall usage and growth rate on the system and any areas that can help be optimized, whether that's storage optimization or additional resources. We can actually go through all the workloads and actually produce reports based on what's happening on the system. Finally, then as well, we have kind of an ad hoc service where we can actually just provide dedicated engineers to work with your end users, and that can be for pretty much anything that covers HPC related work. So this can be application provisioning, any sorts of user issues, any sort of code porting or anything like that. So this is kind of like a bespoke final service that we can offer to ensure that the solutions that we're providing are delivering the performance and expected levels that customers need on site. Okay, so that's kind of covers the introduction to who we are. And with that said, I just wanted to kind of move on to what we're calling the RenAIssance of HPC. And yeah, I mean, part of the motivation for this is that we've been, we've seen a huge shift in the way that end users are consuming HPC technologies over the last decade. And part of the driving force for this has actually been the adoption of AI workloads within organizations. So it's, HPC, when I kind of think back to when I was initially working in the field 20 odd years ago, our customer base was predominantly based of, particle physics users, bioinformaticians, computational chemistry users. It was quite an academic back end. But now when I look at the spread of customers that we're working with, we're starting to see a lot more adoption in the commercial space, and that's getting us into areas that we hadn't been in before. But it's also meaning that a lot of the technologies that we're using are becoming far more pervasive and beneficial across quite a broad spectrum of end users. And it's quite an exciting time to be in HPC. Never before have we had so many technologies and new toys to play with in the lab. And yeah, it's quite an interesting space. So if we look across all of the, I guess the core building blocks of what you'd bring together for a HPC stack, you've got compute, networking, storage, and then software to bring it all together. And across each of these, individual components, there's broadening technologies. There's far more innovation happening in all of these sections. We're starting to see network and storage and compute all sort of merge into one another with the advent of PCI-based fabrics. And how we architect and deliver large-scale solutions is becoming more and more of a challenge, but that's purely down to the options and variants that we have in the underlying components and technologies. So yeah, it's certainly one of the most exciting times I've been in terms of HPC innovation. If we take a look at compute, we've had this historical x86 domination. So for the last easily 20 years or more, we've seen x86 being quite prominent. We've had the rise and fall of AMD and the rise again more recently, which is excellent for end users in terms of having these commercial options available to them. Power 9, IBM have their chip as well in the market, which has been quite successful in certain niche spaces. More recently, we've even seen ARM start to come out with more aggressive CPUs that are more prominent in the HPC space. So we can even see at the top of the Green 500 list, we've got a big ARM system that's up there now. More recently in the last SC19 show, accelerators have been increasing in terms of their adoption and momentum. GPUs have been around for well over a decade, and while their roots may have been quite humble in terms of just running a few compute workloads in GPU cores, we can see their evolution over time towards more AI-based workloads. So you can see the tensor cores that have been introduced in these A100 GPUs that are really starting to be more optimized for AI-type workloads. And you can see even with FPGAs and components like GraphCore, there is certainly a huge market out there for these AI accelerators to be paired with CPUs on systems to bring an overall benefit to the environment. AI has been a huge driving force behind these innovations, as you can see, because of the tensor cores that are added into these environments. And I think as we start to look out even further, you start to see, there's a lot of experimentation and exploration around quantum computing. And yeah, we firmly feel that that's going to play a significant role in HPC in the future as well. So yeah, there's an awful lot of options. There's great innovation happening in this space, and it's certainly interesting times. On the storage side, again, that's not one to be left behind by advances on the CPU side. So every iteration of improvement in performance we get from accelerators and compute and cores, unfortunately, the storage needs to be able to keep up with this as well. So, and AI is sort of changing the way that people access storage also. So what once was, I guess you could have had small hotspots in your data sets that would have been currently been worked on within traditional workloads. With AI, part of the challenge is that actually all of the data is beneficial for optimizing and tuning your neural networks and algorithms. So no longer do you really have these small areas of hot data. You can have vast data sets which are all applicable and all beneficial to tuning the neural networks in time. So you need to be able to not just provide a large amount of storage, but it also needs to be incredibly fast throughout. And I think if you take a look at the the traditional HPC stack, the tiering was very sort of limited in terms of if you could fit your data set into memory, that was the sweet spot. And if it couldn't fit into that, you then typically ended up using your parallel file system to feed it into memory to process it. With the advent of technologies like we have these Optane DIMMs, and we have NVMe, which is getting closer and closer to the CPU. So the Optane actually sits within the memory bus of the overall system architecture rather than across the network. So it allows you very, very low latency, very high throughput and IOPS rates into your actual storage system. It's adjacent essentially to the memory, albeit slightly larger capacity and slightly lower performance. But these can act as an interesting tier in between your compute and your overall back-end storage. So you're starting to see these burst buffers being created and actually configured in part of the compute architecture to actually increase overall performance of your data that's been served up to these accelerators. The parallel file system still plays a huge role as your overall tier for most of the I/O, but it can often sit behind these burst buffers and just continue feeding them in a fairly high performance manner. The other interesting thing is people are tending less to migrate off to tape. Tape it's an excellent and low cost archive solution, but it's in terms of being able to retrieve the data and access it later on for applications, it's incredibly slow. So we've started to see customers really starting to look at object storage as a kind of a longer term campaign storage for certain workloads. And there's technologies out there that actually allow us to put NVMe products in front of object storage to present the object pool overall as a POSIX-like file system, so users don't even have to change their application to interface with object storage. So we're getting to levels of integration with a number of file systems and stuff that will actually use these back-end object storage pools, which can be incredibly cost-effective to configure, and actually, when configured correctly, can actually be incredibly high performance as well. So imagine having the overall a multi-petabyte archive that is still online and accessible to your applications at all times, that can automatically tier up to an NVMe tier to provide access to files at the very, very highest performance levels when needed. So it's again, lots of interesting things happening in the storage market, and architecting a storage solution is no longer just as easy as putting in a parallel file system and everything going faster. So depending on what the workload is, the I/O profile, we may need to look at architecting these things slightly differently. If we take a look at the network side, again, there's been great innovations and advancements in fabrics over the last number of years. I mean, HPC has traditionally been, very open to new network technologies. It was one of the first industries to adopt the InfiniBand fabrics. Mellanox has done a great job making Ethernet also equally highly performant as well. But historically, the network would have really just been used for, storage access to your parallel file system, or perhaps MPI traffic for your application, so to handle, inter-process communications across a low latency, high bandwidth network. I think as we start to look out towards the future, we're already starting to see, composable and disaggregated workloads out there. So, we can actually do things like, passing NVMe over fabric into applications that need that incredibly high level of performance. We're also starting to see the advent of PCI fabrics. So this allows us to actually move, devices across the fabric and dynamically create a hardware configuration that is most suited to the application that's running on top of it. And this is, going to change, I think, the way that people consume resources in the future. So instead of having these static configurations of hardware, you'll be able to put together, essentially chunks or blocks of, be it memory, accelerators, disk, NVMe, and as a workload is submitted, we've recently done some work around integrating this with Slurm, where we can actually put in requests for GPU devices and NVMEs into your job resource scheduler, and the backend PCI fabric can go and create the hardware environment suitable for that application, instead of having to buy systems with these devices pre-populated and perhaps underutilized. So I think there's great excitement again in terms of what the future holds for these types of technologies, and these is something that we're looking at quite aggressively in the lab, and feel that it will have a place certainly in most HPC architectures in the not too distant future. The final part of the puzzle as well then is the software stack. So with all of these advancements in hardware technologies, that can put a lot of challenges, I guess, on local system administrators to be able to provide the environments for users to come in and actually make use of all of these technologies. So what was perhaps historically a HPC cluster may just have been a Linux provisioning system with a scheduler monitoring and alerting on top of it for batch-based workloads. As you start to look at how people are consuming resources today, you've got containers, you've got the emergence of Kubernetes, you've got remote collaboration and visualization, and these can often be technologies that are either not integrated initially with the HPC stack, or they're have to be run concurrently or integrated with existing systems. One of the products we've been working on in the background for the last while is vScaler, and this is a cloud operating system that allows customers to run an on-premise environment that has the same agility and flexibility that you get from a public cloud environment. We've spent the last 6 or 7 years taking everything that we've been doing from the HPC space and layering it in on top of OpenStack, so that we can actually provision environments for research in the most appropriate, high speed and least overhead in terms of administrative burden for research users to come in and collaborate on. One of the white papers we produced recently on this is at vscaler.com/AI, and this is where we actually integrated all of the NVIDIA GPUs. We can support virtual GPUs for things like remote visualization, or even small development environment for people that are looking to do initial investigation or exploration around AI tools and techniques. We've integrated it with Rapids as well, which does a lot of the data analytics and data enrichment side of things. Within vScaler, we can provision virtual or physical, so we can actually spin up bare metal environments without any virtualization overhead for HPC or scale out workloads. We can run Slurm on top of there, we can roll out Kubernetes as well, and it can all be provisioned dynamically, so we can reduce and increase these environments as users tend to move from one to the other. It's completely elastic and it's completely dynamic, so whatever workload is thrown at the system, it can actually adapt to it as well. We've spent a bit of time integrating things like Spark and Jupyter portals as well for interactive analytics. So this is quite useful for people in the data sciences side who want to come in and just work with Jupyter notebooks. We have portals that users can just come in, spin up resources, and just get down to focusing on the science that they're working on. In terms of containerized applications, again with the support of Kubernetes, and even we can do things with Docker and Docker Swarm. They're all fully supported out of the box as well. So whatever your researchers are throwing at your central HPC resource, this platform can accommodate it all. The other interesting thing we have been doing there is we've got a cloud expansion built into this platform as well. So we can actually leverage public cloud resources as part of our clusters. So we can extend, punch a VPN tunnel into the public environment, roll out the exact same compute node image out there, and allow your cluster to we can either replicate your cluster, or we can just extend it out into the public cloud to go and extend your resources dynamically. So anytime there's like a high priority project that has an incredibly short turnaround time, or for certain projects that have just their internal resources are just too overly consumed, we can extend clusters very, very easily. We're also combining that with really embracing Singularity and other containerization tools for applications on our platform. So the ability to have application mobility on public cloud or internally, having the applications containerized, having the data sets ready to be moved in and out, and having the ability to extend your clusters in and out of public clouds makes utilizing these public resources far more easy for the users and far less friction that they're embracing as part of it. So yeah, we see public cloud as being part of most organizational strategies in the future, and we've got the technologies in-house to accommodate that as well. Okay, so I think with that said, I'm going to sort of thank you all for your time, and I'll be handing back over to the team and hanging around on the Teams chat if anyone has any comments, queries, or questions or critiques. Thank you all.
Thanks very much, Dave. So now, as Dave has said, it's time for you to ask your questions. You can use our Q&A tool, which is accessible through the speech bubble with a question mark in it. So get your questions in for Dave. Dave, I'm going to kick off with one here. How can Boston assist with planning if you've got a major refresh coming up in a year or 2 years?
Well, yeah, I mean, the best stage actually to be engaging with us is sort of at that early stage, because I mean, there's a number of things that we can actually do with customers where we can, take their commonly used codes and applications and perhaps run them across a suite of different hardware architectures to understand where the optimal performance and configuration may be for them. It's also a chance to, test a lot of the storage technologies and understand what might be the best platform to use. Even ahead of time under NDA, we still get access to next generation technologies in the lab. So before they're even released, we get them into our labs environment, and they're available for our key customers to come in and actually test on and work on. And that can not only just give you an idea on what the best solutions may be, but it's also a chance to work with our engineers and understand our capabilities. We can work with you in terms of tuning and optimizing applications further as well. So yeah, essentially, in short, just reach out to us at any stage, and we're here to help and work with our customers.
And what about kind of at the first step? How can Boston help?
Yeah, so I guess by the first step, I guess you mean kind of people that have come from a non-HPC background,
Yeah,
but that are perhaps looking to start to adopt HPC
yes.
technology. So how do we get over that first initial hurdle? So we see that quite often in the field. So you have, often an organization has, researchers who are actually doing a lot of their development and work and research on a local workstation, without any sort of realization that this could actually be, put into a centralized cluster. So, some of the challenges around that are, of course, changing people's mindsets. So to assist with that, I mean, we have the Boston Training Academy, who can actually come in and do training and courses around, how to use clusters in their most efficient manner. We can do tutorials and workshops around actually, coding, using workload managers, onboarding users onto clusters, and getting familiar with cluster tools and techniques and best practices. And then, with our HPC clusters, they can start at relatively modest sizes as well, but actually grow over time as users become more, as they start to move more workloads onto their central systems as well. So yeah, we can actually start quite modest and actually grow those systems to be quite significant over time as well as demand increases.
And then kind of once you have your clusters established, what about kind of ongoing services and management?
Yeah, so there's a full sort of suite of services that we can offer. So depending on what your in-house appetite and expertise is, if you just wanted to come in and consume the system as a standard user, we can actually take over the administrative burden by integrating our alerting system with our support system. So if you didn't necessarily have those Linux administration HPC skills in-house, they are something that we can work with our customers on to either train people up to that level or actually take over the day-to-day burden of managing or administering these clusters as well. So yeah, even down to the stage of upgrades throughout the duration of projects, or even retiring systems and migrating data from one system to another. There's a huge suite of services we can offer to make our customers' lives that bit easier.